Many applied math problems involve solving a polynomial equation using factoring. For example, the height of a projectile over time can be described by a polynomial equation, which is what we're doing now. A cannonball is fired from a building that is 260 feet high with an initial speed of 128 feet per second. The height s of the cannonball in feet as a function of time t in seconds can be modeled by the function s of t equals negative 16t squared plus 64t plus 260. So we can see from the question, the height s is in feet and time t is in seconds. So s represents the height and t represents the time. So when will the height of the cannonball be 320 feet? So we know that the height is 320. So that means s is 320. So since I know what s is, I'm going to plug it in here for s and then solve my equation. So negative 16t squared plus 64t plus 260 equals 320. Now I could have put equals 320 on this side or equals 320 on this side. It doesn't make a difference. I prefer it over here just because that's what I'm used to. Now I'm just going to subtract the 320 over to get everything to one side. So when I do that, I'm going to get negative 16t squared plus 64t minus 60 equals 0. So now I can factor this, but I'm not going to factor it quite yet. I'm going to find a GCF to make it a little bit easier. In this case, I can factor out a negative 4 from the whole thing. So negative 4, or it's going to leave me with 4t squared minus 16t plus 15 equals 0. And now I'll factor this because it's a little bit easier to work with than the original. And so I ask myself, what times what? 4 times 15 will give me 60. But when I add the same two numbers, I get negative 16, the middle coefficient. And in this case, it's going to be negative 10 and negative 6. So plugging them into my factored form, I'm going to get t minus 10 and t minus 6. And since this here is a 4 in the front, I'm going to divide both my factors by 4. And so when I do that, negative 4 times t minus, and 10 over 4 is going to be 5/2, and then 6 over 4 is going to be 3/2. Now I'll set each one of these individually equal to 0, so negative 4 equals 0, t minus 5/2 equals 0, and then t minus 3/2 equals 0. So negative 4 equals 0. Can't happen. Just throw it away. Here I can add the 5/2 over, so I'm going to get t equals 5/2. And remember that t is in seconds, so I don't normally call time in fraction form. I typically use a decimal, so I'm going to change it from 5/2 to 2.5 seconds. Do the same thing over here. Add the 3/2 over, and I'm going to get 3/2, and I will go and convert this to normal time like I usually use, which is going to be 1.5. And make sure to use my unit of measure, seconds. So the cannonball will be at 320 feet in 2.5 seconds and in 1.5 seconds. And it makes sense because when it launches off of a building, it goes up and down, and it'll be at 320 here and here. Next, when will the cannonball hit the ground? So if we have this cannonball being shot up and down, when it hits the ground is what we want to know. So when it hits the ground, we can say that its height off the ground is 0 feet. So s is going to equal 0. So when we just take our s value that we got and plug it into our equation, we're going to see how to solve it. So negative 16t squared plus 64t plus 260 equals 0. Again, you could have put it on the left or the right. Doesn't matter. I prefer on the right, but you'll still get the same answer. Again, I can factor this, but first I'm going to take out a GCF because I want it just to be a little bit easier. So I'm going to take out a negative 4. So I'm going to have 4t squared minus 16t minus 65 equals 0. And again, 4 times negative 65 is going to give me negative 260. And when I add them together, I get negative 16. And my two factors that will do this are going to be negative 26 and positive 10. So factor form, t minus 26, t plus 10. And again, my coefficient here leading is a 4. So I'm going to divide everything by 4 and reduce. So negative 4, then t minus and 26 over 4 is going to be 13 over 2. And then 10 over 4 is going to be 5 over 2. Now I set everything equal to 0 again. And as you see, we get another negative 4 equals 0, which I can just throw away right away. T minus 13 halves equals 0. And then t plus 5 halves equals 0. And now I solve. Add the 13 halves over. T is going to equal 13 halves, which again I will convert to decimals, and I'll call it 6.5 seconds. And then subtract the 5 halves over. T equals negative 5 halves, which again I will convert to a decimal, and I call it negative 2.5 seconds. Now, when it comes to distance and time, you can never have a negative time. It's not possible. You cannot go backwards in time. So getting a negative here, no go. But we got a positive over here, 6.5 seconds. So that is good. So when will the cannonball hit the ground? It will hit the ground 6.5 seconds after being launched.